Hey space enthusiasts, ever feel like life's moving too fast? Well, buckle up, because you ain't seen nothing yet. Today we're diving into the fastest lane in the cosmos, exploring 11 objects that make light speed look like a leisurely stroll. From spinning stars to particles so fast they break physics, we're about to take a journey through the ultimate speed limit of the universe. Ready? Let's blast off. First up, the cosmic ballerinas of the universe, neutron stars. These stellar corpses are the densest objects we know aside from black holes. But what really sets them apart is their insane rotational speed. The fastest we found spins a mind-boggling 716 times per second. To put that in perspective, imagine the Earth spinning so fast that a day lasted just over a millisecond. At these speeds, the surface of a neutron star can reach velocities up to 25% the speed of light. That's fast enough to circle the Earth 7 times in 1 second. Black holes aren't just cosmic vacuum cleaners, they're also nature's fastest particle accelerators. Some black holes shoot out jets of particles at speeds up to 99.9% of the speed of light. These jets can stretch for thousands of light years, influencing entire galaxies. Imagine a fire hose so powerful it could spray water from New York to Los Angeles in less than a second. That's the kind of speed we're talking about. Meet S5 HVS1, the stellar outcast of our galaxy. This star is hightailing out of the Milky Way at a blistering 3.7 million MF. That's fast enough to travel from Earth to the Moon in just 6 minutes. Scientists believe this cosmic speedster got its incredible velocity from a close encounter with the supermassive black hole at the center of our galaxy. Talk about the ultimate galactic slingshot. Remember those spinning neutron stars we talked about earlier? Well, PSR J1939 plus 2134 is the current champion. This pulsar is the fastest spinning neutron star we've ever found, rotating about 716 times per second. If Earth spun this fast, the equator would be moving at 2.8 times the speed of light. Of course, our planet would be torn apart long before that. But pulsars, they're nature's cosmic fidget spinners built to handle these extreme rotations. Let's bring things a bit closer to home. The Large Hadron Collider, our biggest particle accelerator, can accelerate protons to 99.999999% the speed of light. That's just 3 meters per second shy of light speed. At these velocities, the protons make 11,245 circuits around the 27-kilometer ring every second. It's like a subatomic Indy 500, but instead of cars, we're racing the building blocks of matter. Now let's talk about the speed champions that Albert Einstein predicted, gravitational waves. These ripples in the fabric of space-time travel at exactly the speed of light. Produced by some of the most violent events in the universe, like black hole collisions, these waves carry information across cosmic distances. They're so fast that when we detect them, we're essentially hearing the echo of ancient cosmic cataclysms in real time. Our very own sun is in on the cosmic speed game too. It constantly ejects a stream of charged particles known as the solar wind. These particles can reach speeds of up to 1 million MF. At its fastest, the solar wind could get you from Earth to Mars in just 2 days. Unfortunately, these particles aren't exactly suitable for space travel. They're more likely to fry your electronics than give you a quick lift to the red planet. Let's zoom out and look at something truly massive. The Fermi Bubbles are colossal structures extending above and below the Milky Way's center. These galactic-scale bubbles are expanding at about 2.2 million MF. Discovered in 2010, these structures are a testament to the violent history of our galaxy. They're like cosmic smoke rings blown out by our galaxy's central black hole, expanding faster than our entire solar system orbits the galactic center. Now we're venturing into the realm of the theoretical. Tachyons are hypothetical particles that would always move faster than light. While we've never observed them, and their existence would break our current understanding of physics, they're a favorite of science fiction writers. If tachyons exist, they'd be the ultimate cosmic speedsters, making everything else we discussed look like they're standing still. But for now, they remain in the realm of imagination and complex mathematical theories. Black holes aren't just about sucking things in, they might also be spitting things out at incredible speeds. Hawking radiation, proposed by Stephen Hawking, suggests that quantum effects near a black hole's event horizon could create particles that escape at the speed of light. While we haven't directly observed Hawking radiation yet, if it exists, it would represent some of the fastest moving particles in the universe, escaping from the clutches of objects so massive that not even light can normally escape them. For our grand finale, let's talk about the fastest movement of all, the expansion of the universe itself. At the largest scales, space itself is expanding faster than the speed of light. Now this doesn't violate Einstein's theories because it's not matter moving through space, but space itself stretching. Distant galaxies aren't moving away from us, the space between us is growing. It's like drawing dots on a balloon and then inflating it. The dots themselves don't move, but they get farther apart. And there you have it, space fans. The 12 fastest moving objects in the known universe. From spinning neutron stars to the expansion of space itself, we journey through a cosmic speedway that defies imagination. These cosmic speed champions remind us that the universe is a place of extremes, where the laws of physics are pushed to their limits and beyond. They challenge our understanding and fuel our curiosity about the fundamental nature of reality. So the next time you're stuck in traffic or impatiently waiting for your download to finish, remember, somewhere out there, particles are zipping around at nearly the speed of light. Stars are being flung out of galaxies and space itself is expanding faster than we can comprehend. If this cosmic drag race has ignited your curiosity, don't keep it to yourself. Share this video with your fellow space enthusiasts, and don't forget to like and subscribe for more mind-bending space content. And here's a question for you. If you could hitch a ride on any of these cosmic speed champions, which one would you choose? Let us know in the comments below. Until next time, keep looking up and remember, in the grand cosmic race, we're all moving at incredible speeds through space, even when we're standing still.